Hello and good afternoon, CSI257 Section 847 students. For the first 8-week term of the spring 2015 semester at Anne Arundel Community College for the Scaling Networks course, Networking 3, today's PacketTracer tutorial is going to be on what we covered this past Saturday, which was Etherchannel. And so we're going to be looking at PacketTracer Activity 3.2.1.3 in this video, and we're going to move on to the other PacketTracer videos which also deal with Etherchannel. So let's go ahead and jump right in here. So configure basic switch settings. It wants us to assign each switch a host name according to the topology diagram. So let's go ahead and start with switch 1, and we'll bring switch 1's window down here. We'll make it a little larger so that we have a little more room. And we're going to go from user exec mode into privilege exec and then into global config, where we're going to say hostname S1 using the hostname command to set the switch's name. Then we'll pull up switch 2, and we're going to repeat this process on switch 2 as well as switch 3. So I'll go from user exec into privilege exec into global config, and we'll say hostname switch 2. And we'll do the same thing here on switch 3. So we'll pull up the CLI, and we'll go from user exec to privilege exec into global config, where we say hostname switch 3. All right, so we've got our hostname set. It says configure all required ports as trunks depending on the connections between devices. So let's go ahead and we'll start on switch 3. It looks like we've got ports, and let me slide that up just a little bit there to the top so we can see a little better what's going on here. So on switch 3, we're looking at interfaces FA021, 22, 23, and 24. If I did a do show IP interface brief, you can see that we can also see here that 21, 22, 23, and 24 are in the up state, right? Okay, so let's go ahead and let's do an interface range, and we're going to say FA021 to 24. All right, so now we're going to say switch port mode trunk, and we're turning all of those ports into trunk ports, and you can see what happened right away is that spanning tree is now having to reconverge. So we've got a lot of orange ports up there because of the change that we just made on switch 3. And let's take a look here. So configure all required ports as trunks. All right, so we'll do the same thing here. We're going to jump onto switch 1, and let's get this done here so that spanning tree can go ahead and do its thing. So interface range, and on switch 1, we're going to be looking at FA021 to 22. And let me make sure we get this right here. Whoops. Interface range 21 to 22, and we're going to say switch port mode trunk, and then we're going to go into interface range GI01 to 2, and we're going to say the same thing, switch port mode trunk. And this is changing these ports from, they were non-trunk ports, we're now changing them into trunk ports, and what that means is that these trunk ports can now carry multiple VLAN traffic, or traffic from multiple VLANs across the trunk ports. And we're going to be ether channeling these trunk ports together to take advantage of the additional bandwidth. And then finally, we'll go on to switch 2, which we'll make a little larger here. And I'm going to say interface range, and switch 2 will start with the gig 01 to 02, and switch port mode trunk. Right, and then we'll say interface range FA0/23 to 24, and I'm going to say switch port mode trunk. All right, So now that we've configured trunk ports on all of the switches, if I say do show interface trunk, we should see that we have the 4 interfaces that we were configuring. Set up as trunks, the encapsulation is automatically 802.1q. And you can see down here VLANs and the spanning tree forwarding state and not pruned. We've got FA024 is being blocked, so it's going to say none. However, VLAN 1, which is the only VLAN right now, is in the forwarding state on FA23, gig 01, and gig 02. And this is, again, this is on switch 2. Okay, it says if the ports are configured with dynamic auto mode, you do not set the mode of the ports to trunk. The links do not form trunks and remain access ports. So the default mode on a 2960 is dynamic auto. And the reason for that is because on an earlier switch model, the 3550, the mode was dynamic desirable. And there were numerous concerns about that, because if you forgot to shut that port down and someone plugged a switch into that port, then it would automatically, it would actively attempt to configure itself as a trunk link with a switch on the other end. And so it was a huge security concern. So to address that, the trunk ports have been put into dynamic auto mode. All right, so let's configure port channel 1. So step 1 here, it says the first Ether channel created for this activity aggregates ports FO22 and 21 between switch 1 and switch 3. So it says on both switches, add ports FA21 and 22 to port channel 1, and it gives us the command that we're going to use there. And then it wants us to configure the logical interface to become a trunk by first entering the interface port channel number command, and then the switch port mode trunk command. So add this configuration to both switches. And let me make sure we're not missing anything here. As you can see, again, I've had this activity up for quite some time, so the score, even though the score is showing 0, if we go and check results, you can see that it'll be checking things off. So let's do that. Let's start off here on switch 1, and between switch 1 and switch 3. So I'm already in the interface range. However, I need to back out of here. I think we've got many more ports in there. So I'm going to say interface range. Right, we're going to pick the ports that we want to have in the Ether channel. FA0/21 and 22. All right, and so I'm going to go ahead and say channel, what do we have here? Channel group 1 mode. And actually, before we do the channel group, let's see if they have the channel protocol command. So the channel protocol command is here. And so what is this command for? And this is as a best practice, you should always run this command on any ports that are going to be participating in your Ether channel setup. The reason for this is that this command dictates which protocols can be configured with respect to Ether channel on the port in question. So if I were to say channel protocol PAgP, which is the Cisco proprietary Ether channel protocol, port aggregation protocol. If I now ran the channel group command, and let's say that I'm a new administrator, and maybe I'm a little confused about the different modes, and I said active, and I hit enter. You can see that it says command rejected, and it gives you an error here saying it's a different type of protocol, because again, we've set the protocol to only accept PAgP, and active is the choice that you would pick for LACP. So here are the choices, and let's talk about these for a second. So if you're setting up an Ether channel, it's very similar, the behavior anyway is very similar to when you're doing trunking. So if I'm doing, if I was going to set up a PAgP, so PAgP, right? So let's remember this is Cisco, CISCO, Cisco proprietary, right? And the two mode choices we have when we're doing PAgP are auto and desirable. Now, these are the modes. Now, the important thing to note about these modes is, remember when we're trunking, right? You can do auto and desirable as well. And it's convenient that the behavior in Ether channel is the same way. So if you have auto on one end and auto on the other end, it is not going to work, right? Not going to form a trunk. If I have auto on one end and desirable on the other, we're going to get a trunk. That's a check mark there for the trunk. If I have desirable and desirable, we're going to get a trunk link. I'm sorry. The ether channel is going to form. I apologize. So the ether channel will form, right? This is going to work. So that's my check mark there. And in fact, that's a terrible check mark. Let's sort that out. There we go. Better check mark. So the ether channel will form just like the trunk links, right? If you have auto and auto on the trunks on either side, the link is not going to form. If you have auto and desirable, then the link will form. If you have desirable and desirable, the link will form. And with Etherchannel PAgP, it's the exact same thing. And so that is going to function for you, right? So if I were to draw a very crooked line down the middle here, if we were to talk about LACP, right, this is an open standard, IEEE, right? And the note here says that it's 802.3 AD. And this was correct, 802.3 AD. This was correct up until a short time ago. It's now 802. And I want to say 3AX is what I believe it is now, right? So it has changed, right? It's AX are the letters on the back of, on the tail end of the LACP IEEE standard. But again, this is industry standard. So you could actually do Etherchannel between a Cisco switch and a Juniper switch, because Juniper switches can do LACP, right? If I'm doing PAgP and I bring a Juniper switch into my environment, unfortunately, I'm not going to be able to run PAgP to do Etherchannel with another vendor switch. So the smart choice is always LACP. And in VMware, when you're doing your VMware servers and things like that, LACP is usually the protocol of choice. And so the modes here are simply active and passive. And they do exactly what you would think. So those are the modes. They do exactly what you think it would do. So active is going to actively try to seek out and form and establish an ether channel with LACP, and passive is going to sit there and wait for someone to tell him, hey, let's become an ether channel. So auto, and now that I'm looking at this here, so auto, it would be, and let's change colors. So auto would be the same as passive, right? And we'll do blue here. Desirable is going to be the same as active. All right. Now, the key thing to know, now I'm saying that they have the similar functionality, right? So in terms of the mode, so desirable and auto or active, they're both going to try to form an ether channel, right? They're actively trying to send those packets and trying to form an ether channel. Whereas auto and passive are not. They're just kind of sitting there waiting for someone to come tell them, hey, we need to become an ether channel. Let's ether channel together, at which point they will then participate. The key thing to note here is that these two standards, PAgP and LACP, are not interoperable. Right? And this is very important. You cannot have, if you have a switch here and a switch over here, and this guy is LACP because he's on this side, and this guy is PAgP because he's on this side, and we've got two links here, and we want to ether channel these guys together, right? We're going to ether channel these guys together. If I'm running desirable mode here on those two links, and I'm running active here on these two links, that is not going to work, right? Because it's PAgP on this side, it's LACP on this side. They're two completely different protocols. They do the same thing, but functionally they're completely different, right? With respect to the way that they negotiate the ether channel setup and teardown. So these are not compatible. And the same thing with the on mode. On mode means there is no protocol, right? So you're literally just turning on Etherchannel with no negotiation of any settings, no checks on anything. And so on mode is also not interoperable with either PAgP or LACP, because on mode, there's no protocol. There's no packets. There's no order of operations with respect to the communication back and forth between the two switches. It's literally sort of the Wild West of Etherchannel, where you turn it on and hope for the best, right? Okay, so hopefully that makes some sense. So let's step back over here. We've set our protocol, and we saw the channel protocol we set to PAgP, and we saw what happens when you try to use LACP. It's not going to let you form that or set that on those ports, because it's expecting that PAgP should be set. So it's asking us to set the desirable command on both switches on both sides. So I'll say channel group mode desirable, and let's do that on the switch 3 side as well. And I'm going to log into switch 3 and go from user exec to privilege exec into global config, and then we're going to say interface range FA0/21 to 22. And we're going to go ahead and say channel, and again, best practice here is to do the protocol to make sure that there's no misconfiguration by someone that might not be familiar with the setup. So then we're going to say channel group, channel group 1 mode, and it's asking for desirable. All right, so there we go. So the next step, it says on both switches add the ports. We've done that. We've done the mode desirable. It says configure the logical interfaces to become a trunk. So it wants us to go into interface. So now before we do that, if I do a do show IP interface brief now, you're going to see that we've got a new interface. We have port channel 1, and he is in an up and up state. So if I said do show ether channel, we can see here that it's going to list out for us the ether channels that have been configured so far on switch 3. So we have a layer 2 ether channel, right? And let me get that out of the way. Slide that guy down there. Okay. So as you can see, we have a layer 2 ether channel, and I was afraid that was going to happen. Let's drag that. There we go. So I've got a layer 2 ether channel here, right? So 2 ports are in there. The maximum number of ports that I can have active at any one time is 8 on the Catalyst platform. So how many port channels? We have a single port channel right now because we've only done 1. Max port channels, it's set to 1, and the protocol is PAgP, right? So show ether channel gives us that information. If I were to do show ether channel, let's clear the screen and come back here, and if I were to do the show Etherchannel Summary, and let me stretch this out a little more so that we can see everything. There we go, little better presentation. So you can see we've got the group, which is group 1, which we created when we said channel group 1. The port channel, the interface is PO1, and that's how we'll refer to it when we go into configure it. You've got your protocol listed here as well as PAgP. And then here are the 2 interfaces that are in this port channel. So we've got FA022 and 21, and they have a P next to them. If I come up here, I can see, what does that mean? It means that they are in, those interfaces are in the port channel. S and U, so the S means it's layer 2, and the U, and where's the U at? There it is. All right, I was looking around for the U. The U means it's in use, right? And so this is what you want to see, right? If in this slot here, if you were to see the capital I, like we did when we forced the configuration on one side, the I means that he's a standalone, which means on the other side, on the other switch, there's nobody configured for this guy to set up with, right? You may also see a lowercase s, which is for suspended. So, but what you want to see are the P's, because that means that these ports are in the port channel, they're up, they're active, and everything is good, because we can see here we have the SU, means layer 2 and it's in use. All right, so let's clear the screen here. And let's step over to our partner switch, which is switch 1. And let's take a look here. If I do a do show ether channel, you can see we get the exact same output. If I do the do show ether channel summary, we get the exact same output. So our ether channel is up, and this is all good news. Let's take a look now at what's going to be asked next of us here. So configure the logical interface to become a trunk by first entering the interface port channel number and then switch port mode trunk. So from here, what I'm going to say is interface PO1, because remember, that's our port channel interface, and then I would say switch port mode trunk. So if I do a do show run, and as you can see here, there are the two interfaces we configured, 21 and 22. We've placed them into channel group 1, and there's our port channel interface. Now from here on out, if I wanted to make a change to the port channel, I want to make those changes to the logical port channel interface, not to the individual interfaces that we configured to be part of the port channel. So FA21 and 22, we're not going to go under those interfaces to make configuration changes anymore. We would do it under the port channel 1 interface. All right, so we're good there. So we verified the status. We did the show Etherchannel Summary, and let me keep scrolling down here. So we did our show Etherchannel Summary. We actually did the show Etherchannel. Let's also do a do show interface trunk. And as you can see, and this is what we were talking about in class on Saturday, this is what I was looking for, was to see VLAN 1 in the spanning tree forwarding state and not pruned, right? And this is where you will see that. So up here we've got our interfaces, gig 01 and 02, but we also now have our newcomer, port channel 1. You'll notice it no longer references the physical ports, FAs 21, 021, and 22. It now references the port channel interface. And this is what we want. This is good output here. So we've checked this out. The ether channel is up. It looks good. So now let's move on to part 3, where we're now going to do an 802.3ax LACP ether channel. And it says AD, but again, it's changed. It's now capital A, capital X, which means it's a standalone IEEE standard. Lowercase like this, it means it's a part of, it's an amendment to an existing standard. All right, so in 2000, the IEEE released 802.3 AD. It's an open standard of ether channels. So let's go ahead. It says configure the links between switch 1 and switch 2. We're going to use our gig ports as an LACP ether channel. Use a different port channel number on switch 1 than 1 because we've already used that. So let's go ahead, and I'm making sure I'm not going to miss anything here. Verify port channel 2 status. So the show commands. All right. So let's jump on to switch 1. We'll start here on switch 1, which we're already on. So let's go ahead and say interface range GI01 to 2. Right? So now what we're going to say is channel protocol, right? Remember, it's not asking us for that, but this is definitely a best practice to make sure that you don't put a protocol on the port that's unexpected, right? So, and then we're going to say channel group, and we're going to go ahead and use the number 2 and mode. And what are the modes again for LACP? Well, with PAgP, it was auto and desirable. With LACP, it's active and passive. So we're going to say active because we want it to actively participate to try to form that ether channel. Let's jump over to switch 2 here, and we're going to go from, whoops. All right, and the reason that it's trying to do this is I have IP domain lookup on, right? So sometimes when you type the wrong command, if you see this, it's trying to resolve the single tick that I accidentally entered in. And so this will time out here shortly, and it's because I've got the IP domain lookup on. I haven't turned it off, and so we're going to end up with that error. Let me see if I do control, there we go. Control Shift 6. Okay, so we'll go from user exec to privilege exec and then into global config, and we're going to do the same thing. Interface range GI01 to 2, and we're going to go ahead and say oops, keep misspelling channel. Channel protocol, LACP or LACP, and then channel group to mode active, right? All right. So we've now set up both sides. You can see that the links have gone down. I'm pretty sure those interfaces are up, so I'll say no shut. So there we go. We've got both sides set to active. So let's take a look now. If I do show Etherchannel, and let's make this a little larger here. You can see that right now it's showing a layer 2 Etherchannel because we're on switch 2, remembering that switch 2 doesn't have anything else configured on it. So we've got a layer 2 Etherchannel. Now, this is very important to understand when you see this output here, where it says max ports 16. And Jackson in class on Saturday had a great question, which was, what is the maximum number of ports that you can have in an LACP Etherchannel? Now, the maximum number of ports is 16. However, you can only have 8 that are active at any given time. And if we had 16, we would have 8 that would be in what is referred to as hot standby mode. And so what does hot standby mode mean? So let's say that we had 16 connections from port 1, 2, 3, ... all the way up to 16. So if we took the first 8 ports, and these first 8 ports, so we'll put 8 here, this is our active ether channel, right? These are the active ether channel links. These other 8 ports from 9 to 16, right? These guys would be in hot standby mode. And what hot standby mode means is, let's say port 1 between the 2 switches fails. The next port in line is going to simply come up to maintain our status of 8 active ports. So what you literally have here with these 8 ports are 8 ports that are not passing any traffic at all. They're part of the ether channel. However, they're in hot standby mode, which means they will not pass any traffic, right, unless we start to experience failures in these links over here, at which point these guys, our hot standby ports, will then start to come online. 1 for 1, and it's a 1 for 1, right? So if I lose one link here, one guy comes on, one new port comes online out of hot standby mode, so then 7 would be left. If 2 and 3 both failed at the same time, after 1 had failed, then 2 more ports would come online immediately, leaving me with 5 hot standby ports at the end. So again, this is sometimes for new learners, this is a point of confusion where it says 16, but you can only have 8 active. But you can put 16 into the group. And remember, on Saturday, we placed 10 into a single group and then experimented with the failover, and we were able to see how that hot standby worked. So I've got 2 ports right now, 1 port LACP port channel right now. Again, your max port channels. Now that's not links. That is the maximum number of port channels that you can have on this switch, which is different. It is not, let me change my color here. Oh wait, it is not, and these are probably the, oh, didn't change my color for me. It is not the same. Those are not the same, right? And then our protocol, LACP. All right, so let's clear our screen here, and let's jump back in. So we've got switch 2 configured with LACP. Let's go back to his partner, which is going to be switch 1. So do show ether channel, and you can see he's showing 2. However, if we do a do show run, and let me make sure that I'm looking at this right, between switch 1, and I don't believe we had configured switch 1, although the information is there. Maybe we had configured switch 1. I wasn't sure if we had done that. So it looks like both ends. So do show Etherchannel Summary. What do we see? we see exactly what we want to see, right? All good news. Port channel 2, which was from the channel group command, LACP. And so what does this tell us? That on the same switch, you can run PAgP, LACP, and on ether channels, all on the same switch, right? You just can't run them together at different ends. So what I mean by that is the PAgP, I can't have PAgP on one side and LACP on the other side and expect that it's going to form an ether channel. Same thing, I can't have LACP on one side and on the other side and expect that it's going to form an ether channel, right? So again, that doesn't prevent us, though, from saying, you know what, for this port channel, let's use PAgP, because maybe that's going to a Cisco device, and we know it's always going to be a Cisco device. So let's use PAgP, the Cisco proprietary. And then maybe port channel 2 is going to a Juniper device. So it's possible that this guy could be linking up with a Juniper. Whoops. Sorry about that. There's this button on the pen that causes me issues sometimes. Maybe this is going over to a Juniper EX3200, right? And maybe this guy is going over to a Cisco 6500, right? So this is where you may see this, okay? So it's not to say never to use PAgP, but if you want to leave your options open, LACP is definitely the way to go. All right, so let's clear our screen. And let's see what we've got next. So we verified our status. We're good. So configure a redundant ether channel link. Now we're going to configure port channel 3, and it's going to have us do this between switch 2 and switch 3. So we're going to be using FA23 and 24. And what is the mode that it would like us to use here? On switch 2, passive. Okay, so we're going to use passive and active. So this is also going to be an LACP ether channel. So I'm going to say interface range FA023 to 24, and we're going to go ahead and say channel protocol, right? You want to make sure that we lock this in. And again, this becomes even more relevant when you are using, and I was scrolling back up there looking for the output we just had. If you're using PAgP and LACP and on, it's probably a good idea to set this. That way there's no confusion about which protocol is going to be allowed to be configured on these ports to form my ether channel. So we've done the channel protocol. Let's now do the channel group. And I'm going to say channel group 3. Mode is, wait a second, I'm missing something here. I just mistyped that. So channel group 3, sorry about that. And we're going to set the mode to, and I believe on switch 2, it's asking us to set it to passive. So again, the passive option is going to indicate we want it to use LACP if and only if the neighbor is detected as somebody who is in active mode. So on the other side, I'll set it to passive and we'll see what happens. So we'll say mode passive, and I'll hit enter, and as you can see there, the interface has come up. So now let's go into interface port channel 3, switch port mode trunk. It's not asking for that. I'm going to go ahead and run that anyway to be sure. And so now if I do a do show ether channel, excuse me, you can see that we've got group 2 and group 3. However, we know that group 3 is not actually fully functional yet. So if I were to do a do show Etherchannel Summary, aha! So here's where we're going to see the I, and this is exactly what that means, is he has no partner. What that means is it's not partner locally, right? Because here's his local partner, so he's good there. What the I means, standalone. Which means on switch 2, we've got it configured, we're ready to go. However, over on switch 3, there's no partner for me. There's nobody on the other side for me to establish an ether channel with. So what do we see? We see SD, and we know what the S means, layer 2, right? So what does the D mean now? The D is down, and this is what you do not want to see. You don't want to see these I's, and you don't want to see a D in here, because this means that while it is configured on this side, it is not configured on the other side. So let's jump over to switch number 3. And we'll go from user exec to privilege exec, and then into global config, and then interface range mode for FA023 to 24. Whoops, let me make sure I get that right. 24. All right, so again, we're going to say channel protocol. I'm having a lot of problems with typing channel today. So we're going to say channel protocol LACP. We're going to say channel group is going to be, we used 3, and our mode, and I'm going to set the mode to passive. And let's see what happens. So it shows the line protocol going up. Do show Etherchannel Summary. Okay, so switch 3 shows that it's standalone and it's down. And what about switch 2? Do show Etherchannel Summary. Again, in standalone, both of those ports are in standalone mode, so they've got no partner on the other side. Again, in passive mode, LACP is passively waiting. It is sitting here waiting for the other end to say, hey, you over on switch 2 or you over on switch 3, let's do a LACP Ether channel together. At which point the passive switch will then start to participate. But until somebody actively says, hey, let's form an Ether channel, it's not going to work, right? So let's see if it's still, yep, it's still holding, right? You can see that. It's still down and it's in the standalone state. So let's rerun this command and let's put in, let's put in here active. All right. So now when I do the do show Ether channel summary, you can see that we're still down, and that's okay. And let me go and make sure I go into the interface here, port channel 3. We're going to say switch port mode trunk. And so do show Ether channel summary, right? So we're still down, and as you can see, spanning tree is reconverging because the links show orange, and if I were to do a do show span right now, if I can get it quickly enough, aha, what state are we in? We are in the learning state. So spanning tree is learning what it needs to learn. And there you go. It is now transitioned into the forwarding state, right? So that was very fortuitous that we were able to catch that when those links were orange, showing us that they were in the learning state. And again, spanning tree is reconverging at that time to try to make the determination based off of whomever is the root bridge, which we're lucky enough here to be on switch 3, and it says this bridge is the root. So we know that on the root bridge, all root bridge ports for the VLAN in question, which is VLAN 1, are going to be in a state of forwarding, and the role of those ports on a root bridge will be designated. So let's take a quick peek here then. If that's in forwarding, let's look over at switch 2. You can see we've got the links up there. So what do we have? So port channel 2 is root and in the forwarding state. However, it shows FA23 and FA24 as alternate blocking for VLAN 1, right? So if I were to do a do show Ether channel, you can see that we've got group 2 and group 3. If I do a do show run so that we can see the two different interfaces, we've got port channel 2 and port channel 3. However, when I do a do show span here, we're only seeing port channel 2. We're not seeing port channel 3. But let's drop back over here to switch 3 and see what we see. So switch 3 is only showing us port channel 1, right? It's not showing us port channel 2 for the VLAN. And let me make sure. Yep, it has not shown us that. All right, so we've got one step left. We've done our verification, and now it's going to ask us to use the show commands to verify the status of port channel 3, look for the protocol used on each port. So port channel 2 is not operative because the spanning tree protocol placed some ports into a blocking state. So unfortunately, what it says here is that those two ports are gig ports. However, when we look up here, you can see that we're showing green on our gig ports. Let's continue on to make sure what what this says here. I want to make sure we've got all of our steps down. So to restore these ports, configure switch 1 to be the primary route for VLAN 1, and we're going to use the macro here. So what I'm going to say is spanning tree, and remember, we're going to set for VLAN 1, we could say priority here, right? I can do a question mark. You could use priority, but we're going to use the macro, which is root primary. And what that actually does behind the scenes is it runs the command spanning tree VLAN 1 priority 24576. And what it's doing, though, is it's checking to see what is the root bridge priority, and as long as it's not lower than 24576, that would be my setting. So when the default is 32768, this command will set it to 24576. So we're going to set switch 1 to be the root bridge for VLAN 1. So do show span. And you can now see that port channel 1 and port channel 2 are both in the forwarding state, and they're both designated ports because, again, switch 1 is the root bridge, so all of its ports are going to be designated. So this port channel is a designated port channel in the forwarding state. Over here, it's a designated role for the port, and it's in the forwarding state. Let's come down and take a look at switch 2 for VLAN 1. You can see now that we've got port channel 2 is now up. The cost is 3. It is a root port because it is on switch 2. This port channel, which is the logical interface now, this is the closest interface to the root bridge. So therefore, this is a root port. What about the other one? So we don't see port channel 3, right? Because it is blocking. If I come over to switch 3, let's do a do show span. And you can see that we see the port channel here, and it's our root port. So we know that it's this guy right here, port channel 1, and he is in the forwarding state. However, FA23 and 24, those are blocking ports, right? Those ports are blocking, which is why we had the statement down here. It says port channel 2 is not operative. This was earlier, but now we can see that port channel, port channel 3 is not operational because we switched who the root bridge was. And so this logical interface here that we created, port channel 3, is in the blocking state because its member ports are in the blocking state. And so that's why we've ended up where we're at. So let's check our results here. Again, make sure we didn't miss any assessment items. And we didn't. As you can see, our score is here. I apologize. I've had this up. I brought it up last night and then just left it up. So that's why it's a little buggy here that it won't show the score, but we know that we've got it correct. All right. So this was our first PacketTracer tutorial on Etherchannel from Chapter 3 in the Scaling Networks course, PacketTracer 3.2.1.3. Hopefully this has cleared up any confusion you might have had with Etherchannel. It's a great opportunity to configure Etherchannel to see how it actually functions. All right. Have a great week, and I will see you all on Saturday.